All right. So unfortunately, we missed class on Thursday, and we don't get a makeup class, so we still have to cover Objective 6. So in addition to doing your ALEKS homework, you should watch this video because it is the lecture that we would have done in class. It's all the same examples. So before you start this, go ahead and print out the lecture, the mini lecture for this section, and you can follow along. So in Objective 6, we're talking about two different things. First, we're going to talk about composition of functions, and then we'll talk about inverses. So, composition of functions. In the last lecture, we used regular algebra to combine functions. So, we created a new function called f plus g of x by taking the function f of x and adding to it the function g of x. So now we're going to define a new symbol that's not a plus or a minus or a times or divide. We're going to define this new symbol, and it's a little o. And when you see this symbol, you read it out loud as of. So if I have the symbol or the notation f of g of x, this is function notation. It says create a new function called f of g with the argument called x. And the way we define this is we're going to take f of g of x. So now I'm using these big square brackets so you can see that this is function notation inside of function notation. So the input that we're going to put into the function f is whatever the function g, whatever rule that is. So let's I've got two functions. The function f of x, which is 3x minus 1. So that's a machine. It takes its input, times it by 3, subtracts 1. And then the function g of x, which is 2x. So the function g of x is a machine. It takes its input and it timeses it by 2. So now what I want to find is f of g of x. So I want to find f of g of x, which is f of g of x, right? Using the rule. But g of x is 2x, so I want to do f of 2x. So I'm going to replace g of x with 2x. But I could do that. That means take the function f and replace all your x's with this thing, 2x. So I have 3 times 2x. And then subtract 1. So I can do that. 3 times 2x is 6x. Subtract 1. So the new function, which is called f of g of x, is the function 6x minus 1. So this is the function f of g of g x. Of f. I know you want to read it as fog, so this is. I know, but read that g o as the word of. F. Okay, let's try going the other way. But f of x is 3x minus 1. So I'm going to do g of 3x minus 1. But that notation says take the function g and replace all of your x's with 3x minus 1. So I get 2 times 3x minus 1, because that's what the function g does. It takes its input and it timeses it by 2. So now I can simplify this one just a little. If I distribute that 2, I get 6x minus 2. Now I know that f of g was very close to this, right? F of g was 6x minus 1. But 6x minus 2 and 6x minus 1 are not the same function. Okay? So when you compose f with
Here's
g,
my two functions.
and then when you compose
f of
g
x
with
is
f,
x
they
minus
don't necessarily
2
come
all
out
over
to the
3.
same thing. And then g of x is 3x plus 2. So first I'm going to do f of g of x, which is f of 3x plus 2. So that says take the function f, replace all your x's with 3x plus 2. So this is going to equal, instead of x minus 2, I'll have 3x plus 2 minus 2. And then big divides 3. Okay, well, order of operations, we have to do the top first. So 3x plus 2 minus 2, that makes just 3x. So I have 3x over 3, which simplifies to just x. Okay. So when I compose these functions, f of g of x, I get out just x with the function g. And let's try going the other way. Let's replace my x's with f of x. G of f of x. So that's g of x minus 2 over 3. Because that's what the function f is. So in the function called g, I want to replace all of my x's with x minus 2 over 3. So that's going to make 3 times, and then x minus 2 over 3, and then plus 2. So now we have to simplify here. I've got 3 times this fraction, x minus 2 over 3. So those 3's cancel because there's a 3 times on top and then a 3 on bottom. So that makes x minus 2 plus 2. And then the minus 2 and the plus 2, I mean, that cancels too. So this also equals just x. Now that's kind of interesting. It turns out that when you compose two functions together, if the backwards and the forwards composition both equal just x, then those two functions are called inverses of each other. So I'll say that again. If you compose f of g, and then you also compose g of f, if both of those come out to just
about
x,
what
they
does
simplify all the way to just
inverse?
x.
How do we know
then
if
those
a
two
function has an
functions
inverse?
are called inverses.
Does every
of each
function
other.
have an inverse?
No. So first we're going to look at the first property of inverses. That when a function has an inverse, it's called one-to-one. It's called one-to-one. And to be one-to-one, your function has to pass the horizontal line test. So the horizontal line test works just like the vertical line test. So you're going to pass horizontal lines over your graph, and if any of those horizontal lines touch the graph more than once, then the function fails the test. It's not one-to-one, and an inverse does not exist. If it does pass the horizontal line test, then the function is one-to-one, and you can find an inverse function. So I know there's more rules on this page. We're going to come back to the rest. Okay, let's just talk about one-to-one test. So the first thing I want you to see is that there are three different directions that all mean the same thing. Are these graphs one-to-one? Does the inverse exist? Does it pass the horizontal line test? All of those directions mean the same thing. So sometimes in ALEKS, it will ask you the question in a different way, and you have to know that that means do the horizontal line test. So let's look at this first one here. If I pass horizontal lines over my picture, do any of the horizontal lines touch more than once? So yeah, those last three touch more than once. So this one, the answer is no. This graph is not one-to-one. An inverse does not exist. It does not pass the horizontal line test. Okay, let's try number 2. If I pass a horizontal line over this graph, some don't touch, but then most of them are going to touch more than once. So this graph does not pass the horizontal line test. It's not one-to-one, and there is no inverse function. Okay, third graph. I'm going to pass horizontal lines over the picture. Do any of those horizontal lines touch more than once? No. So this graph is one-to-one. It is invertible, so an inverse does exist, and it does pass the horizontal line test. Let's try number 4. So number 4, there's only one point that's or one line that's a little questionable, and that's this line right on the x-axis. Right? Every other line, I think it's clear to see that every other line will only touch once. But I claim that this line only touches once. And that's because one of the points that it touches is included, and the other one has an open circle, which means not included. And so technically, this horizontal line and all the other horizontal lines will only touch the graph one time. And so this graph is invertible. It does pass the horizontal line test. It is one-to-one. Okay, last graph, number 5 here. Again, this is definitely a function. Okay, it's a function. It's got 1, 2, 3, 4, 5 points on it. Each x got only one y, so it is a function. But now I'm looking to see if this function is invertible. And you'll see most horizontal lines only touch the graph maybe once, except this one down here, which is going to touch the graph 3 times. All those points are included. And so this one is not invertible. It is not one-to-one. It does not pass the horizontal line test. So remember, you can be given a graph, or you can be given a function as a graph, or you can be given a function as a rule, right? F of x equals. So if you're given a graph and the question is asking if an inverse exists, you're going to see if it passes the horizontal line test. Let's talk about what do you do if you have a function with function notation. Can you find an inverse? So first things first, if you have a function called f of x, then its inverse is called f inverse of x. So notice that's f with the symbol -1 kind of high, almost like a power. This is not a power, it's just a symbol, and it represents the word inverse. So if you see the notation f with a little -1, that's called f inverse of x. So now, how do you find an inverse if you're given an equation? So the first 3 of these steps is just changing your notation. Okay, so the first step is to change from the notation f of x to the notation y, because that's easier to work with. And then, and this is kind of the heart of the problem, we're going to let x equal y. So basically, in your equation that you have in front of you, you're going to switch all of your x's to y's and all of your y's to x's, and then solve for y. So now solving for y is the longest part of the problem. Sometimes it goes very quickly. Sometimes you have to work at it. The last example we're going to do in this lecture is an example where you kind of have to work for the y. But then once you solve for y, you just replace it with the F inverse notation. Okay? So now let's try it. Here's my function. F of x equals x cubed minus 9. X cubed minus 9. So the directions say find the inverse function. So if I have f of x equals x cubed minus 9, the first step was to drop that f of x notation and write it as a y. So I have y equals x cubed minus 9. And then step 2 was to let your x's be y's and your y's be x's. So instead of writing y equals x cubed minus 9, I'm going to write x equals y cubed minus 9. So I interchange my x's with my y's. Okay, so now I have to get y alone. I have to get y alone. So the first thing I'm going to do is I'm going to add 9 to both sides. X plus 9 equals y cubed. And then how do you get rid of y raised to the power 3? So when you want to get rid of a power 3, you have to take the cube root on both sides. So I'm going to take the cube root on both sides. So now cube root and cube cancel. So on that right-hand side, I just have a y. And on the left-hand side, nothing cancels. So I have cube root of x plus 9. So now you may be thinking, what about plus or minus? You only use plus or minus when you're taking an even root. So like the square root or the fourth root or the sixth root. That's when you tack on a plus or minus. But cube root, you don't. So now last step is to rewrite your function, but use inverse notation. So instead of writing y equals, I'm going to write f inverse of x equals cube root of x plus 9. So now, we talked about, like I started out saying that two functions are called inverses of each other if you compose them one way and you compose them the other way and you get out just x. So let's practice deciding if these two functions are inverses. So in this case, we're basically checking our work. Now on ALEKS, what they do is they'll give you two random functions and they'll say, are these inverses? And you'll do the composition both ways. Okay, so we've got f of x.
Okay, so now we're going to take the two functions that we just found
and f inverse
and
equals
determine
if they
plus
really
9.
are inverses of each other. Now in ALEKS, what they normally do is they give you two random functions and they say, are these inverses of each other? But I'm saying here that you found the inverse, or you think you found the inverse. Can we check? So the function f of x was x cubed minus 9, and the function f inverse of x was cube root of x plus 9. And so we're going to compose them back and forth and see if we did the work correctly. Again, this process would be the same if I just gave you two random functions and said, are these inverses? So here we go. I'm going to take f of f inverse of x. f of f inverse of x. But f inverse is cube root x plus 9. So I have to take the function f and replace all of my x's. So all my x's here, I have to replace all of them with cube root x plus 9. So I would have cube root x plus 9, and then that whole thing squared, or sorry, cubed, and then subtract 9. So now cubed and cube root cancel, so I have x plus 9 minus 9, and plus 9 minus 9 cancel, and so I just have x. So far so good. I composed them this way, and they came out to just x. Now I have to compose them the other way. So I'm going to take the function f inverse of x, and I'm going to replace all of its x's. So I need to find with x cubed minus 9. X. So I'm going to take my function f inverse. So remember, the function f inverse is the cube root all my x's with x the input cubed add 9. So the input here is x cubed minus 9. And then plus 9. So input plus 9, and then cube root. So now here, plus 9 minus 9 cancel, so I have the cube root of x cubed. And then cube root and cubed cancel, and so I have just x. So it turns out that these two functions are inverses of each other. The last way that you can be given an inverse question is to talk about the graph of a function versus the graph of its inverse. So the reason we did the function notation one first is because it actually tells you the rule for graphing. So in the function notation rule for finding an inverse, step 2 says let x equal y. So switch all your x's to y's, all your y's to x's. This is actually the same rule for if you're given a graph. When you're given a graph, you are going to switch x's with y's. So if you've got 2, 3 on your graph, then 3, 2 will be on the inverse graph. Now this is technically flipping over the line y equals x, which is a diagonal line, but that's kind of confusing if you have like a crazy function. It's not always easy to see. So if you just list coordinates from the original function and then flip-flop them, graph the new coordinates. So now in this next example, I'm going to make you do a little bit more work. I'm going to give you the function notation, and I'm going to make you find the coordinates first, and then flip-flop the coordinates to draw the inverse graph. All right, so here's our function, f of x equals 3x plus 2. Now normally we would give you a graph and then have you find the inverse. But we're going to go one more step, and I'm going to say first graph the original function and then find its inverse graph, okay, without going through finding the actual inverse. So what I need to do is I need to plug in some x values, find the y's that go with them, and then graph that line. So in my function f of x, if I replace x with negative 2, I get 3 times negative 2 plus 2, which is negative 4. Negative 1, so 3 times negative 1 plus 2 is negative 1. 3 times 0 plus 2 is 2. 3 times 1 plus 2 is 5. And 3 times 2 plus 2 is 8. So now, generally, when we draw a graph, these are the x's that we pick, negative 2, negative 1, 0, 1, and 2. And we're going to talk more about that in Objective 7 and 8. So now, let's graph that. I've got So it's hard to graph points on this in this program. So I'm just going to draw the line. You should draw the points. Oh, boy. -2, -4. So this is about the line here. Not a very good graph. Okay, so what we want to do is we want to graph the inverse. Okay, we want to graph the inverse of this graph. So we're going to take these coordinates and we're going to flip-flop them. So -2, -4 becomes -4, -2. And then -1, -1 stays -1, -1. 0, 2 becomes 2, 0. 1, 5 becomes 5, 1. And then 2, 8 becomes 8, 2. So I'm just flip-flopping all 5 of these coordinates. And now I have to draw them. So these ones I'll plot so you can see where the picture comes from. So -4, -2 is down here. And then -1, -1 happens to be on our old graph. And then 2, 0. And then 5, 1. And then 8, 2. So I'm going to draw these as one line here. And this is the graph of f inverse of x. The first one was the graph of f of x. Okay, so if you have a list of coordinates or you have a graph, what you do is you flip-flop the coordinates and graph those, and that will be the new function called the inverse function. I want to do an inverse. Now, technically, find the inverse what happens where you have to do a little bit of work flipping over the line to get to your answer. Okay, so so if you can picture flipping a graph over that blue dotted line step is sometimes a little tough. You can do it that way, but I think that's hard to see how to approach it. So I just flip-flop. So last example, find the inverse of f of x. Okay, so last example here, 3x minus 1, big divides 4x plus 5. So first step is to change your f of x into a y. Okay, second step, interchange x's and y's. So replace all your x's with y and replace all your y's with x. And now solve for y. So remember that means get y alone. So first things first, I don't like that this is a fraction, so I'm going to just times my bottom up. So I have x times 4y plus 5 equals 3y minus 1. Now at this point, you have y's on both sides of the equals. Okay, so now this happened when we were doing logs. We had x's on both sides. So this is kind of like that. We need to get all of our y stuff on one side and all of our not y stuff on the other. So I can't do anything with these parentheses here, so I'm going to distribute my x. So I have 4xy plus 5x equals 3y minus 1. So now I want to get all of my y stuff together. So here's a y here and here's a y here. Okay, they're on different sides. So I need to move this guy over. So I'll have 4xy minus 3y plus 5x equals -1. But now I've got something on the left-hand side, which does not have a y in it. So it's a not y thing. So it's got to move to the other side. So I'm going to subtract 5x from both sides. So I have 4xy minus 3y equals minus 5x minus 1. So now what's nice is that I have y's, all my y's on one side. I've got, I'll do a different color here. I've got a y here and a y here, and they're both on the same side of my equals. So I can factor that off. I'll factor the y off the left-hand side, so I have y times 4x minus 3 equals minus 5x.
So 4x minus 3 is in parentheses.
1 equals minus 5x minus 1. Y times, so y times minus 4x minus 3 minus 5x minus 1. And now I've got y times something, so I can divide by that something. I'll divide on both sides. Y equals minus 5x minus 1, big divides, 4x minus 3. So my last step is to switch from y equals into f inverse of x equals minus 5x minus 1 over 4x minus 3. So now, this is your final answer. Okay, this here is your final answer. If you were doing this and you decided to get your y stuff on the right-hand side and your not y stuff on the left-hand side, yours will look a little different, but it's still technically the same. So it's still technically right, which is the best kind of right. So let me just show you. If you were doing this by yourself and you moved the y's to the right and the not y's to the left, you will have f inverse of x equals 5x plus 1 over 3 minus 4x. And that 2 is correct. Okay, these both represent the same function. So that 2 is correct. So now, this is the end of your lecture. You should be able to finish your worksheets and your homework based on this. So this is exactly what we would have done in class. I hope everybody had a good hurricane. I'm glad it didn't hit us directly. And I will see you next Thursday. Objective 6 is still due in Alex on Wednesday night, and we still have a test on October